guys, welcome to this video. We're just going to be looking at the different reaction types. So we're going to go through synthesis, decomposition, single replacement, double replacement, and combustion. The first one I'm going to do is synthesis. So for this one, what I've got is some, a little bit hard to see on the camera, but I've got some magnesium metal. Okay, and I'm going to make some magnesium oxide. Now, there's a little bit of magnesium oxide already on this, which is why it's kind of more a dull grey. Right, if this was pure magnesium, it would be quite bright in colour. Okay, but you'll see quite quickly when we're making magnesium oxide, because essentially this metal is going to burn. Okay, it's going to burn with a really bright white flame. Okay, so obviously it's not going to be an issue for you guys because you're looking at it through a camera, but when it starts burning, I'm going to be looking away. So I'm going to drop it into my Bunsen burner here. Right, the blue flame is hottest. Okay, and there you go. You can see it there. I'm looking away because I don't want to burn my retina. Okay, let's see if we can get the other part going. But you would have seen there that you had a very bright white flame. Here, I'll do it one more time, and I'll show you so you can kind of see the metal there. It's quite rigid and solid. If we get that in there. There she goes. Really bright white flame. Okay. And you can see there now that it is kind of twisted and curled. Okay, and if I just kind of flick that, you'll see that it breaks very easily. Right, it's kind of like ash, and that is the magnesium oxide. Okay, the next thing we're going to do is a decomposition reaction. So what I've got here is copper carbonate. Okay, as you can see, it's copper 2 carbonate, so CuCO3. Okay, and it's, you can kind of see there, if I'm trying not to spill this, it's kind of a greeny colour. So if we're just thinking back to, you know, how can we tell that a reaction has occurred that we learnt a couple of weeks ago? Right, one of those things, right, we get a new product. Okay, so we get a colour change. Right, as one of them. We saw a flame. Okay, we saw a change in chemical properties with our last one. This one we're also going to see a colour change. Okay, so there you go. It's nice and green. Yeah. What we're going to do using heat. Okay, we're going to decompose this into this copper carbonate into copper 2 oxide. Copper 2 oxide is black, so we should see this green turn into a black. Okay, so I'm just going to start heating that up. Okay, and we could also, if we wanted to, we could have weighed the test tube beforehand, we could have weighed the test tube afterwards, and we would have seen that we got a significant difference. But if we're going to do that, we'd also want to include our waters of crystallization. Okay, because there would be some water in there, so we would take a sample and we would measure it, and then we would heat it up. Oh, well, we would have to, we couldn't heat it up because obviously heating it is making a difference, right? We can see there that it's turned white black. Okay. Now, if I wanted to, we'd have to dehydrate it, going back to my point before, and work out what our waters of crystallization is. Okay, so we can see that it's changed. Now, one of the ways we can test for carbon dioxide, okay, if we've produced carbon dioxide is heavier than air, so by holding my test tube up like this, it's going to keep any carbon dioxide that I'm producing in there. Now I've got a nice flaming splint. Carbon dioxide doesn't support combustion, so let's see, and boom, it goes out straight away. Okay, and that's gone out. So there's carbon dioxide in this tube, okay, because it no longer supports combustion. If I was producing something like oxygen, I put it there, oh, woof, okay. Or if I was producing hydrogen, like we're going to in a second, we'll get a little bit of an explosion. Okay, but we can see there, all right, we've definitely had a chemical reaction occur because we've turned that from green to black, okay, and I proved that it was carbon dioxide because it put out the flaming splint that I put in there very quickly, okay. So that's a decomposition reaction. Okay, next up we're going to look at a single replacement reaction. Okay, so again I got my magnesium, just going to cut that. So I'm going to pop that in my test tube, magnesium in my test tube. Okay, here I've got some HCl, some hydrochloric acid. Okay, and essentially, alright, the magnesium is going to replace the hydrogen and make magnesium chloride, sorry, and we are going to then get hydrogen gas released. Okay, so let me squeeze a good amount into here. There we go. Sorry, just having. Okay, so you can see it's quite clearly fizzing away there. Okay, try not to burn my arm on the thing. What I'm going to do is I'm going to hold my thumb on there, shake it up, okay, and essentially what I'm doing now is I'm trapping all the hydrogen gas, and if we listen very carefully we should hear a pop. Okay, that pop noise, and you can see the flame kind of be disrupted, is the hydrogen gas burning. Okay, so which is actually a combustion reaction as well. So we got 2-for-1 deal here. And if you were here and you felt this test tube, you feel that the test tube is getting warm from the reaction. Okay, so we got heat being produced as well. Alright, those were some pretty good pops. When I was practicing this, I didn't get as good pops. So we'll see if we can get one more. Okay. Okay. And you can also see, if you have a look in the test tube now, that the magnesium is completely gone. Okay, and then double replacement reaction. Okay, so in this case I've got my, just going to remove the Bunsen burner more out of my way. Okay, I've got potassium nitrate and lead nitrate and potassium iodide. Okay, so they're both ionic compounds that I've dissolved in water, right? And we've seen this one before, but we'll use it again because it's super helpful. Okay, we're going to put our lead nitrate in there. Okay, careful not to get that on my fingers. Lead is a poisonous heavy metal, so I don't want to ingest it. Alright, so that's in there. Then potassium iodide, okay, soluble organic compound, ionic compound, and I put that in there, and you can see that I get a good bright yellow precipitate there. So essentially what has happened there is the lead, and the lead is combined with the iodide, and the potassium is lead combined with the nitrate. Okay, potassium nitrate is soluble, so it stays in the solution. Okay, and the lead iodide is not soluble, so it forms a precipitate or a solid. And if we just, it's probably hard to see on the camera, but I can see it, it will settle out, and I'll eventually end up with a clear colourless solution and a bright yellow solid down the bottom. It's kind of, it is happening, but it's probably very hard for you guys. You might be able to start to see it there come out. Alright, I'm going to pause this video here and I'm going to try and get a good combustion reaction, but if I don't, you've got one going on in front of you pretty much the whole time of this video, okay, where I'm burning natural gas and I'm producing water and carbon dioxide. Alright, I'll be...
A few moments later.
Okay, welcome back. So what I've done is I did the same reaction that we did before, the single replacement one with magnesium and hydrochloric acid, and I tried to fill this balloon with some hydrogen. Okay, hydrogen reacts with oxygen. Alright, it combusts. Alright, this is the fuel they use for space rockets, and the right mixture, it will burn, okay, and it will give thrust for the space rocket, and the wrong mixture, it will explode. And that's kind of what I'm hoping here. So hopefully we get a bit of an explosion. So let's us find out. Yeah, that worked well. So we got a bit of an explosion. So that was a combustion reaction. It wasn't, let me just turn the gas off, because the combustion reaction blew out the flame. It wasn't a full-on explosion, okay, because even with my naked eye I could see the flame, and what I'll try and do in a second is give you a slow-mo of that if I can make it work on the editing software. On that, hopefully you got to see your synthesis, decomposition, single replacement, double replacement, and then finally our good combustion reaction. Hey guys, welcome to round 2. When I finished filming round 1, I realised that the camera angle wasn't the best, so this time less of my face, more of hopefully the explosion. So again, hydrogen in the balloon. Alright, we've got a heat source to get the combustion going in our Bunsen burner, and then oxygen in the atmosphere. So let's try this again. Yeah, again. That was a good one. So I'll try and put that one in slow-mo, and you can see that again. Hopefully that was some fun. See you guys later.